In our last video, we went over how to use conditionals to achieve particular effects. If I press the left mouse button, make this happen. If I press the N key, make that happen. Today, this is a fun one. We're going to learn how to declare and initialize variables and how you can use those variables to achieve particular effects like this. And this will be today's assignment. By the end of today's lesson, you should be able to code this from scratch. So let's do this again. Roll the intro. All right, first step as always in our process, let's give this file a name. So we're going to go to File, Save As, and I'll call this 5A Variables. Okay, let's begin with the definition. What's a variable? A variable is a place where you store a particular value in the computer's memory. That's very broad and vague, but the more you play with this concept, the more you realize, well, that's about the best way you could define it. So let's first create a variable, which is called declaring it. So there's many types of variables. Let's just start with this called int. So int, well, let's just go like this. Int, we're going to say w equals 100. Okay, int is a type of variable that is an integer, which means it can't store a decimal place. So it can have 1, 2, 3, negative 4,000, 0, but it can't be like 1.1, nor can it be 1/3, because 1/3 would be 0.333. That's a floating point variable. So let's create a floating point variable too. So float, and let's just say h equals 50. Now, there's other differences between these two. So first of all, an int, as I said, can only store integers. Float can store decimal values. So I could put like 50.6, for instance, and maybe I'll just leave it like that. So don't worry about which variable do I use where. In general, let's just stick to floats. But I just wanted to introduce you to these. It's not worth the discussion yet at this point. I first want to get you comfortable with using variables before we worry about the particulars of which variable to use where and why. So let's go void setup or startup, I guess. Okay, void setup, and let's make a canvas of size 800 by 600, my favorite canvas size in the universe. And let's go void draw. And let's do something with these variables that isn't very interesting at all. I'm just going to create an ellipse, and I'm going to say, hey, make an ellipse. Let's put it in the center. So width divided by 2, height divided by 2. And we're going to give it the width of W, ooh, and a height of H. Now, you all can predict, if you've done your mathies, that, hey, this is like substitution, right? I'm going to take the W equals 100 and plop that right in there. And same thing with the H. I've made another variable called H equals 50.6, and that number gets plugged right in there. And hooray, I've made an ellipse with a width of 100 pixels and a height of 50.6. Now you might say, well, why didn't I just plug the numbers in there? Well, there's reasons we want to do it this way, and let's explain those reasons in a second after you save. So save, and then let's make a recursive equation. All right, now we're going to do something Mondo cool with this stuff.
That's right, boys. Mondo cool.
You don't know how long I've been waiting to use that meme. You have no idea. Okay, let's go. File, save as. We're going to call this 5B recursive equation. I can barely read my font on my screen. It's tiny. Okay, so now let's keep a lot of this stuff the same. Let's just delete this. Okay, so let's call, we're going to make A, instead of A, W, and H, we're going to make an A and B. And let's call A 50. And B also 50. And let's make an ellipse. And we're going to make the ellipse located at A. So that's its x value. We're going to give it a height of 100 and a width and a height of 50, 50. And there it is. We got a ellipse there, a circle. Yay! Okay, doesn't do anything interesting yet. Now let's take advantage of some copy pasta. I'm going to go Control C and I'll Control V, or you can type it and then Control T to line it up nicely. And I'll make this B and I'll put this at 200. Okay, 2 ellipses, no big deal. But now the recursive equation. This is going to be amazing. We're going to say A is equal to A plus 1. And B is equal to B plus 1.1. And let's run these and I'll explain what's going on. So look at that. We've created motion. And look at the trail it leaves behind it. Pretty cool, right? I just find that so satisfying. It's like seeing behind the curtain, you know, for the first time. Like, oh my God, this is how you create motion using equations. That's super cool to me. All right, so what's going on here? This takes a moment to get used to if you've never seen this, if you've only seen this in the context of math, because how could a thing be equal to itself plus 1? But that's not what's going on here. What's actually happening is we're saying the new value of A is equal to the old value of A plus 1. So initially, when I run this, A is equal to 50, right? So the very first time this runs, 50 gets plugged into here. And then I run this equation. A, which we don't know yet, we're going to figure out what the new value is. A is equal to the old value of A, which is 50. So 50 plus 1 is 51. Now that number doesn't do anything at this point. We've just changed the new value of A to be 51. We execute this, we go back to the top. And now the ellipse plugs in the value of 51. So it was originally at 50, and now one frame later it's at 51. So it's going to take the x value and move it over by 1. And so on and so forth, right? And same thing for B, except because B is a floating point number, I can add a decimal to it. So by the way, watch, if I try to run 1.1 here, watch what happens. See, we see down here a type mismatch. Float does not match with int. I'm trying to add a decimal to a variable that was defined as an integer. That is not possible. So there we go. So let's run that one more time just so we can be satisfied. Again, super cool. Notice the trail it leaves behind. We could solve that. In fact, that'll be part of the assignment, or maybe not. We'll see. But yeah, that's how motion is created. And so when you see your sprites moving along a screen, this is how it's done. Isn't that nuts? This is it. This is all that they do. They get a little bit more complicated than this, but fundamentally, all you're doing is taking a variable and altering its value. And that variable is tied to a particular object or a shape, and this is how you move it. That's how it works. All right, let's make it a little bit more complicated. All right, save that last one. So File, Save, and let's go File, Save As. Let's call this 5C Reflection. And I'll explain what I mean. So let's create some new variables. I'm going to make a variable called float x, and I'll set that equal to 50. And by the way, getting you more comfortable with coding vocabulary, when you create a variable, when you name it, it's called declaring a variable. When you give a value to that variable, that's called initializing that variable. So I have declared it and initialized it or given it a value. Now, let's clear all this out and let's put our ellipse at x 100, 50, 50. And let's go above here. Let's make a black background to put this ellipse on. And we're going to go x equals x plus 1. Oh, that's not what I wanted to do. X is equal to x plus 1. And let's run that. Okay, so yay, we have our ellipse moving across the screen. This time it's not leaving a trail because we're redrawing the background each time. Now, in brief, there's a way to do this briefer. And you could go, as opposed to x is equal to x plus 1, there's a shortcut. You can say x plus equal 1. And I deleted my closing hamburger bun. There it is, it's back. And look, it does the same thing. It's shorthand. So no big deal there. Now, let's do something else here. We're going to create a new variable called float x increment. X increment. And as opposed, let's give it a value 2. X increment, let's set that equal to 1. Okay. As opposed to saying x plus equal 1, let's just say x plus equal x increment. And let's run that. And, well, no surprise, we get the same effect. And again, to remind you all, what's happening is we're taking the value of x, which is 50. That gets plugged in here, which draws the ellipse at 50 pixels to the right. Then I run this equation. It takes that value of x, adds x increment to it, which is 1. So now it becomes 51. When you cycle back to the top and 51 gets plugged in here, well, now it's going to move a little bit to the right? 1 pixel to the right, and etc. It's going to keep redoing this over and over. Now, doing this gives us some options. This is where it gets particularly cool. I can say if the value of x, so if x is greater than the width of the screen. If x is greater than the width of the screen, let's do the following. We're going to set x increment equal to negative x increment. Now try to absorb that for a second. Whatever the value of x increment was here, it's going to make that the opposite, right? So x increment was 1. But when x, the position that controls our ellipse, when that gets to the width of our screen, instead of adding 1 to it, we're going to say, hey, x increment now equals negative 1. So now every time this equation runs, what do you think is going to happen? And if it's obvious to you, great. If it isn't, think for a moment before I run this. Really think about this, because you've got to get how these values interplay with one another if you want to start creating your own functions. All right, let's run it and see. So no big deal here. It's moving to the right, moving to the right. And let's see what happens when it hits the right wall. Boom, it bounced. It bounced because when the value of x, which is the value that gets plugged into our ellipse, became greater than the width of the screen. So when the value of x became 801, we ran the following conditional. We said, hey, x increment is ordinarily equal to 1, but now we're going to make it equal to the opposite of itself, or negative 1. So now when this equation runs, we are going to bounce it off the wall. Here, let's speed this up. Let's say it's 10. This will go quicker. 10 times quicker. Boop! Bounces back. And you can already see how you might get at something like Pong. Now, can't you? All right, let's complicate things a little bit further. All right, here's your first assignment. Make this happen. Make a ball that bounces when it meets the bottom and the top of the screen. And one other key thing, if you look at this carefully, notice that the ball is bouncing the moment it hits the top and the bottom of the screen. Whereas previously you saw the ball embed itself in the side a little bit. So a lot of, you're going to be repeating a lot of what you've just learned, but just in a different direction, of course, and then adding a little bit of complexity. So go for it, and I'll give you the answer shortly. All right, now it's time for the answer for today's assignment. So I'm first going to code it the way that you probably would have coded it based off what I taught you, but then I want to show you a little bit better and simpler way to code it. So some things as you would expect. I made a variable to control my y position, y equals 50, and then I made a variable to control the rate at which the y coordinate changes. I call that y increment. You could also call that y speed. And all right, black background, white fill, nothing new here. I add to the y variable plus equals y increment, nothing new here. But a couple new things. First of all, I make it bounce off both the top and the bottom walls. So to bounce it off the bottom, I say, hey, when y is greater than or equal to height minus 25, because the radius of our ball, I'm trying to follow it, boop, boop, the radius of our ball is 25 pixels because the diameter is 50. So if I subtract 25 from it, it'll bounce the moment, not when the center meets the wall, but it'll bounce, well, 25 pixels further away, which is the side of the ball. And so I had to make two separate conditionals, one that bounces it off the top and one that bounces it off the bottom. But let's do this in a slightly better way. First of all, as opposed to using 25, let's speak in general terms. Let's make a ball radius. So I'm going to make a variable called int r. I'm going to set it equal to 25 for the radius of the ball. Now, for the width and the height of the thing, I'm going to go r times 2 there, and I'm going to go r times 2 here. And then now what I'm going to do is I'm going to say height minus the radius and radius there. And now you're going to get the exact same effect, but it's controlled better. And now what's cool is I can change the ball to anything. So I can make a ball 50 pixels big and it's still going to work. And it's always going to work no matter how much I scale it. So this is a better way to go about it. Okay, pretty cool, right? Now, second thing here. I haven't taught you about the OR operator yet. So what I'm basically saying is, hey, if you encounter the bottom, reflect the ball. If you encounter the top, reflect the ball. But now let's do something else. We're going to use the OR operator. OR is two vertical slashes. So I hold shift and hit the key above your enter like this, two vertical slashes. So this in the logical sense means OR. So if y is greater than or equal to the height minus the radius, or y is less than or equal to the radius, let's reflect it. Now you get the same effect with a little bit less coding, and you're introduced to the OR operator. And that's it for today's lesson. Again, check out my book if you like. It covers all the same things I did here in the lecture. And we are going to, I'm splitting this lecture in half because I didn't want it to run too long. We're going to finish up with some stuff about random variables, and then you're going to make your fun little screensaver effect. So see you in the next one. On the previous episode, we made a ball bounce up and down. Today, we're going to make it a little bit more complicated. We're going to code gravity. Basically, that means an acceleration. But that acceleration only applies in the downward direction. And we're going to also add another effect here, which is called dampened harmonic motion. And this is basically to simulate what an object would bounce like in real life. So you could join this if you're entirely new to the series and you just want to learn about gravity. This is a great place to jump in. Or just continue along with me if you're here for the full ride. All right, let's do this. All right, let's analyze the motion we're trying to create. We're beginning with this. Ball bounces, and every time it hits the top wall, it reflects, and every time it hits the bottom wall, it reflects. We're going to flip it to this, that it's only going to bounce when it hits the bottom wall, flies up, and accelerates downward, bounces off the ground, decelerates on its way up until it reaches maximum height, falls back down. Furthermore, this ball is progressing slowly to the right, And that's about it. So let's try to achieve all these effects one bit at a time. The first thing I want to do is change all these to floats. Now you can use these interchangeably, like I said, and I recommended a while ago that you use floats just in general, just easier practice, because then when you want to use a decimal point, well, it's easy. So here we are, changed all my ints to floats, no difference. Now, let's do something useful here. Instead of every time it hits the bottom of the screen or the top of the screen, we reflected it, right? We said, hey, that speed, which was set to 10, well, when it hits the bottom, you're going to set it equal to -10, which means now it's going to move upward, right? But instead of this, let's take y increment and we're going to multiply it by -0.9. And now let's watch this. So hopefully you can see this effect. Every time it hits a top or a bottom wall, it slows down a little bit because I'm taking the previous speed and multiplying it by 0.9. So it goes from 10, and then I multiply it by -0.9, and it becomes -9. Then I multiply that by -0.9, and then -9 is going to become +8.1, etc., right? Every time it hits, it's going to be diminished in speed by 90%. So that's our first effect. Of course, we don't want it to bounce off both walls, so let's get rid of that effect too. Oh, of course, as I always forget, let's go File, Save As, and I'm going to call this 5E. Let's call it exactly what it is. Dampened Harmonic Motion. Okay, now let's only make it bounce off the bottom wall. And that's simple enough. Boom. Boom, bounces, and then it's going to continue on upward forever. That's fine. We're going to make it so that it'll never be able to go all the way up. Now, prior, we made this variable x that I didn't do anything with. So let's do something with it right now. I'm going to make another variable called float x, and let's also change things to speed. I called it increment, but let's just call it x speed and y speed for now. So I'm going to call that x speed. Instead of y increment, I'm going to call this y speed. And then I'll change all these to y speed. Maybe that's a little bit simpler. Don't know. But you can pick, this is Burger King, you can have it your way. God, that's terrible. Okay, so nothing new yet. Now I need to use that x speed. So we're going to go as follows. Let's set x speed equal to a value such as, I don't know, 1. And I'm going to apply the x speed here. X plus equal x speed. Let's run it. And of course, I am operating on my x variable. I'm adding speed to it every time this thing iterates, but I'm not using it in my equation here. So let's plug it in here. And there we go. Now we can see it slowly progress to the right as it bounces in and out of existence. And by the way, let's start with this thing on the screen, because look, I'm starting with it on the left side of the screen. I'm going to take, well, I'll show you a trick. I could set x equal to r. But look, there's a problem here. I'm referring to r before I defined it down here. So what I want to do is take this and put this underneath here. And I'm going to group some things together. I'm going to group, let's go like this. I'm going to group my y variables together. Let's go like this. Again, organization is super important in your coding. There we go. Let's try that. Okay. That looks better. Now, it's time to add gravity. Real simple. Let's create a variable called gravity. Float gravity. I'm going to set it equal to 1. And let's organize some things again here. We're going to put our gravity here with our other y variables because it's operating in the y direction. Let's get rid of that space. And I'm going to put this variable up here, my x stuff there. Line that up, and then I'm going to use my gravity. And here's the interesting part. Gravity doesn't operate on the y position, it operates on the speed, because that's what gravity does. Gravity is a constant change in velocity over time, not position over time. So let's run this and see what happens. So it looks like it's working, and boom. We had this issue here. Let me run it again. Looks like it worked and then got stuck already on the second bounce. So, super common glitch in coding. This is what's happening. As the gravity speeds up the ball, it can speed it up so far that during one of the cycles of code, or one of the frames, I'm not too sure which it is, it passes beyond the border of the screen. So far, so here's the border of the screen and here's my ball. It's underneath it, right? Okay, here's my ball. It passed underneath it. So now it's underneath it, and then we run this equation, y speed equals y speed times negative 0.9. So that's going to say, oh, the ball's beyond the edge of the screen, so bounce it up. But now it bounces it up, but here's the problem. It's still beyond the edge of the screen. So now it bounces it back down, bounces it up, bounces it down. Boom. And then you get this effect. It gets stuck beyond the borders of the screen. So there's a super simple solution to this. All you do is you say, hey, once it is beyond the border of the screen, set it positionally equal to HEI-GHT equal to the edge of the screen. So if the ball, we're trying to do this the moment it meets the edge of the screen, we're trying to reflect it, right? But let's say it passes beyond the edge of the screen. Well, no problem. Once it passes beyond the edge of the screen, you just set it equal to the edge of the screen. And then now you run this equation. Boom. And there you go. Now you're working. Super important code trick to have in your back pocket, because when you're doing collisions, you probably are going to run into this glitch. When you're making things like Pong or Basic Sprite, basically anything that involves collisions, which is a video game, right? You need to know this trick. So super simple solution. Now, in order to explain how gravity is working, I've created another simple code here. And let's watch this. And I've set it equal to a frame rate of 1 FPS, which is sad times for gamers. Now you can see as time is going by, this ball, every time this whole code iterates, it moves further down the line. So let's try to understand what's happening here. Notice it gets paused at the top before it starts to move. Okay, so let's take a look at this carefully. I've got the Y position initially equal to 50. So the first time I run the ellipse, it's going to draw it right at 50 pixels down from the top. And then I run this equation, y plus equal y increment. And in this case, my y increment is 0. So it's going to take 50, add 0 to it. So the y position just stays at 50. Okay, nothing changed. But here's the kicker. The next thing, y increment plus equal gravity. So I'm going to take y increment, which was initially 0, and add 10 to it. So now y increment is going to be 10. So finished up all these codes, loops back to the top. Next time it goes around, y is still going to be 50. That's why the ball stays in place for 2 iterations or 2 cycles. So y is still going to be 50. But now finally, we're going to take y and add y increment to it. But y increment was previously changed to 10 because we added gravity. So now we're going to take the 50 and finally add 10 to it. So now it's going to be at 60. But we're going to rerun this equation again. This is a lot to follow. So we're going to take that 10 and add gravity to it, another 10. So now y increment is going to be 20. And maybe you see where this is going, right? So now, next time around it runs, again, it's going to be plugged in at 60 for the second iteration. But the third iteration, once it plugs in again, it's going to be moved by not 10 pixels each frame, but then by 20 pixels. And then it's going to be moved by 30. Every time this equation iterates, you move the ball further. That's an acceleration. And if this is a little bit confusing, what I recommend you do is you create sample numbers and you plug it in, and then you iterate this. Be like, all right, first time this thing runs, this is going to be this value, this is going to be this value, and this is going to be this value. Loop back to the top. Plug in your numbers. I have all my students do this to make sure they truly get it. Because if you don't truly get it, you won't be able to manipulate it. All right, that's the end of this video. I'm going to go on to how to use random variables in the next video. And we're going to finally make our screensaver effect. I actually split it not into 2 videos, but 3 videos because I think this deserved its own video. So see you in the next one. All right, today's lesson is about random variables. The first thing we're going to do is learn how to create this, which is actually surprisingly simple. It's only about 6 lines of code. And then we're going to use the lesson we got out of this, plus everything we've learned previously, to code this. Our very own funky, like DVD style screensaver. And there's a lot going on here. Notice the ball accelerates a little bit over time. And if you let this run for long enough, it's going to start creating its own glitches. But yeah, this looks pretty cool. So yeah, this is today's lesson. Hope you enjoy it. Let's go. All right, let's learn about random variables. First thing, let's create a new file and save it as, let's call this 5F random variables. First thing, let's create some standard variables. Float, we're going to create a variable for the width. I'll set it equal to 50. And let's create a height. Let's make that slightly different at like 55. Now, let's draw a canvas of size 800 by 800L, of course, because, because reasons. So 800 by 800. And now let's go void draw. And now to implement our random variables. The way you create a random variable is as follows. You first specify the type. I'm going to create a floating point style random variable. Then you're going to give your variable name. I'll call it X. And then use equals random. So your name of your variable equals random. And now you specify the range of that random variable. Well, I always want my random variable to appear on my canvas. So I'm going to start at 0, because remember you draw it according to the top left corner, for a rectangle anyway. Anywhere between 0 and the entire width of the canvas minus the width of our rectangle. So that way it'll never move beyond, the right edge will never move beyond the right wall. And now same thing for our y variable. I'm going to say random, and I'm going to place it anywhere between the height of the canvas and the height of our rectangle. And now all I need to do is use those 2 random variables I specified. So we're going to say a rectangle, and I'm going to draw it according to X, Y, W, and H. And that is all you need to do, and let's run it. And there you go. Take a look at that. I love this. I think this is super cool. I can't believe you can do this with only like 6 lines of code. And it reminds me of that one character, Naruto. One of the members of Pain. Man, does that out me as a nerd. But it's so cool. Like, I just think this is such a gnarly effect. It's got this 3-dimensionality to it as well. Yeah, pretty cool, right? So I want you all to understand that this is occurring continuously because every time this iterates, X is being redefined. And so too is Y. So because those are being redefined all the time, every time void draw iterates, it's looping continuously. So what happens if I take these out and I put this up here? Well, first of all, we're going to run into one little problem. And here, I'll run this a couple times. You'll notice we're kind of confined to the top left corner. And maybe some of you know why this is the case. I don't even know why it's working at all. But the reason why it's confined to the top left corner is you actually haven't specified yet the width and the height of the canvas. So you're referring to a thing that hasn't yet happened. And I don't even know how this is working, to be honest. It's very weird. But what you should do is I'm going to specify this to 800 and this to 800. Now, I'm going to run this over and over. See, this only executes a random variable once because it's occurring in our initial variable declaration area, right? Our variable declaration and initialization area. This floating point random, we're only creating X as a random variable and Y as a random variable one time. So it's only going to draw the random variable one time. It's only going to create a random variable one time and thus draw a rectangle in a random place once. So I'm going to Control Z and put this all the way back and run that again. And now we're back to our old effect. So hope that all makes sense. Really cool. Again, really, really cool.
That's right, boys. Mondo cool.
Okay, I said that plenty. Save this, and now it's time for your assignment, which is a good culmination of everything we've worked on up to this point. I want you to make this effect. So, you're going to make a ball that bounces off the screen. Every time it hits a wall, it accelerates slightly. Be careful in how you do that. You don't need to make a continuous acceleration function. Just make it accelerate every time it hits the wall, just a little bit. I've also given the circle a little bit of opacity or a little bit of transparency so you can see the previous circles. And notice towards the end, this thing accelerates so fast that it basically glitches out. Don't worry about that. You don't have to worry about achieving this particular effect. That's just because of the values I chose. So let's run it one more time. Nope, not that. Let's run this one more time. So make a ball that bounces the moment it hits the edges of the canvas. It randomly changes a bunch of colors. There's no border around our circle, as you noticed. It has a little bit of transparency. And yeah, that's about it. So really rack your brains over this one, I hope, or maybe it's simple for you. And again, always do the assignment to the best of your ability before I show the answer. It's going to be a lot more valuable. This is how you truly learn coding. All right, see you shortly. All right, it's answer time. So let's go File, Save As. I'm going to call this 5G Bouncy Colorful Ball. That's plenty. And let me just clear this all out and let's start. So I'm first going to make a variable for the radius of our ellipse that we're going to keep drawing over and over. And let's create some variables for its X and Y position. And I'm going to set it equal to R to begin with. So that way I'm ensured when I first spawn the ball, it's always going to spawn in the canvas. That's important. And I'm going to make different variables for the X speed and the Y speed. And the reason I'm doing that is because if I give them the same value, it's always going to bounce at a 45-degree angle. And I don't want that. I want it to move slightly different in each plane. Let's make a square canvas of size 800 by 800. And now void draw. Now you notice that that ellipse had no boundaries around it, so I'm going to go no stroke on the ellipse to get rid of any black border around it. Now here's the fun part. Notice that it was randomly changing all different sorts of colors. You need to make sure you make a separate variable for red, green, and blue that randomly changes. If you go float C for color and then you plug that random color in, well, let's say the random value is 100. So it's going to randomly generate a 100, but that 100 is going to be plugged into the R, the G, and the B value. And what's going to happen is you're going to randomly produce different shades of gray. You don't want to do that. We want multicolored. So because of that, you have to create a different variable for each color. So we're going to say float R. You can use int, by the way, too. Let's call it red, because I can't use R, because I already used R for the radius. So red is equal to random, and let's do it anywhere between 0 and 255, and with actual parentheses, not backwards parentheses. And let's take advantage of some copy pasta. I'm going to Control C and Control V that a couple times, Control T to line it up. And I'm just going to go G, and then I'm going to go B. There you go. Float, red, G, B. Now, let's plug those in for a fill for our ellipse. So fill, red, G, and B. So that's the fill of the ellipse. Now let's draw the ellipse. Well, the ellipse is going to be drawn according to its X, Y coordinate, and its radius times 2. Because that's what a diameter is. It's radius times 2. Who knew? All right, now let's move our ball. So we're going to move our ball by going X plus equal X speed, Y plus equal Y speed. I hate my spacing. Y plus equal, there we go, Y speed. Cool? So now we're creating random values for our color. We're plugging them in for our ellipse. We're drawing our ellipse, and now we're moving our ellipse. Now, time for the collisions with the walls. We're going to say if x is greater than or equal to the width of the canvas minus r, which again is going to collide at the moment the edge of the ellipse hits our canvas, not the center. That's why we have to subtract the radius. So the first thing I want to do is make sure it never pops outside of the edge of the screen. We're going to set x equal to width minus r. Probably is not going to matter for this one, but again, good practice. This is a good thing to do for your collisions. X is equal to width minus r. And now let's reflect it, but I also said let's speed it up each time it hits the wall. So we're going to say x speed is equal to x speed times negative, what goes 1.03. So every time it reflects, it's going to gain 3% speed. Hope that makes sense, right? Because and it reflects, right? It's negative, so it's going to flip the direction, and it's going to multiply. Its speed is going to go up by 3%. Let's take advantage of some more copy pasta here. Control C, Control V. And we're going to say when x is greater than or equal to width minus r. So we're going to say when x is less than or equal to the radius, we're going to set it equal to the radius. Control T to line it up. And then we're going to bounce it. Now let's do the same thing for the y direction. If y is greater than or equal to the height minus the radius, let's set y equal to the height minus the radius, which again is just a double check in case the ball moves outside the boundaries of the screen and we get caught in this jostling problem. And then let's accelerate this as well. I'm going to give it the same y acceleration. Actually, let's give it a slightly different one. Let's see what that looks like, because that's probably going to produce a different pattern overall. Kind of curious. All right, I'm going to copy pasta here too. Boom. And I need a Control T. Oh, that's better. All right, so let's go like this. Boom, boom. And then set y equal to r. And now finally, I need one final brace to close off our void draw loop. Let's run it, see what happens, see if I got it right. All right, there we go. Boom. So, pretty satisfying. Looks really cool, I think anyway. We got this thing slowly speeding up over time, colliding the moment it hits the boundary. And, oh, I brought up, I wanted to add a little bit of transparency. So let's put that back in here. Under the fill, I'm just going to give it a transparency of like 175. So it's decently opaque. Remember, maximum opacity is 255. So there we go. Now you can kind of see some of the previous circles underneath it, especially as it speeds up. Let's speed this up even more, huh? Let's start with the speed of like 10 and 12. All right, let's run that. There we go. Okay, so yeah, we've achieved our desired effect. And as it moves faster and faster, the circles are going to become further apart. And you get this really cool effect in front of you. All right, so that's about it. Our last assignment, our last lecture tomorrow, or whenever this is for you, is to create our paintbrush program. And so looking forward to that all. Again, I'll always plug the book again. If you're curious about learning this all in nice written form, I'm going to make a book on this, or I'm writing a book on this currently. It'll sell for $2.99 on my website. I'll leave a link in my description below if you're curious. But yeah, after we finish our paintbrush tutorial series, you've learned the basics of coding. I'm going to teach you how to code a basic video game, Pong. But that'll be in a future series. So, all right, see you in the next one.